with another screencast about how to draw an LFOM using the new Agua Clara Python package. So, we have to enter Python. And now we can use the convenience import, which is from aguaclara.play import star. So this is only to be used for interactive playing around, kind of sets up your environment well. And now, so that actually imported LFOM into our namespace. So what we can do now is my LFOM, so we can create an LFOM object. And the first thing we need is a flow rate. So let's say 30 liters per second. And we'll grab a head loss at, so a head loss. So this is the total height that there will be orifices across. So it's the maximum flow head loss, to be exact, of the plant. Sorry, that should be centimeters. So like that. Yep, so that created an LFOM object. So now if we inspect that, like you can do my LFOM dot n orifices per row, and you'll see there's 13, then 9, 5, 4, 4, 3, 2, 3, 3, 2, 3. Okay, so I'm guessing the reason that there's not just one at the end is because the spacing between the rows was such that a drill bit that was so large enough to make it so that there was only one orifice could not be used. Otherwise, it would run into the to the whole one row down. So now let's draw that in Onshape. So we just do my lfom.draw, and yeah, so we see the everything change. Now there's the numbers that we were talking about with that last 3 orifices on top. It's a 10-inch diameter pipe. So for whatever reason, sometimes these strings will be left with the old configuration rather than updating to the new one, but you just click on it and it'll state the new one. So the diameter of the holes is 1 inch, and we can see that should conform to my lfom.orifice diameter 1 inch. And then if we wanted to know what the error would be, we can do my lfom dot error per row. I think that's what it is. Yeah, so it just calculated it. So you can see 2% error on the first row. It's always going to have the worst error there. And then the error kind of gets better until you get 0.7% on the top row. So if you wanted to take an average of that, you could just do np.average of my lfom.error per row. All of these various parameters of the class will be documented. So no need to memorize what those parameters are. So you can see the average across all the rows is 0.76%. And now, just to play around, let's push this to the extreme. We will draw an LFOM that is, I don't know, 100 liters per second, and it'll span 50 centimeters. So now you'll notice that this won't update until you do my LFOM.draw. Okay, so that is a 100-liter LFOM. The OD is 18 inches. Um, that OD is not normalized for actual ODs, so that is still to be done. The holes per row look like that, and the diameter of the holes is 1.75 inches. And I'll just show one more time with a lower flow rate so we can see when it transitions to just having one hole at the top. So we'll try that. Yeah, so there's just one hole at the top now. Cool, that's it. Happy LFOM playing.